Woohoo, welcome back. Today we're going to be doing a little more work with rational functions and how to sketch their graph. And this one is a little bit more exciting because in addition to being covered in rabbit fur, it is fully factored for us. Woohoo! And normally when something's factored for us, we're very excited. But in this case, we're actually going to have to multiply it out anyway. But it is nice to see that we've got a rational function and we've got two binomials, the product of two binomials on top, the product of two binomials on the bottom. And the first thing I'm going to do is go ahead and multiply them out. Now, through the magic of television and YouTube, I already have this, but, play along from home. Go ahead and multiply these out in your head, but I've already done it. No mess, no fuss. Okay, there we go. So this is our function g of x. It is definitely a rational function. I've got a polynomial on top and a polynomial on the bottom. The top polynomial is second degree. The bottom polynomial is second degree. And the nice thing is we know what the zeros of these two polynomials are. So that's going to help us later on. To begin with, though, we're going to have to figure out exactly what's going on. So let's take a look at both. And here, in the original state, we can see that there are actually two zeros in the denominator. When x equals 1 and when x equals -2, and those are going to be a problem. So right off the bat, our domain of g is do not let x be 1 or -2. And remember, you go with the opposite. So x minus 1 gives us 1, x plus 2 gives us -2. So it's the opposite of the sign. So we already off the bat know that there are two vertical asymptotes. Now, for the horizontal asymptote or asymptotes, we're going to have to do some more investigation. There are two ways to go about this, and I talked about this in a previous video. One of the ways to do it is the short form is as x gets really big, g of x starts to, actually, I don't want to do that. I don't want to do an equals. What I want to do is I say g of x starts to look a lot like 2x squared all over x squared, which is equal to 2. And so that suggests a horizontal asymptote. And that would be absolutely fine if you want to stop there. It's pretty safe. With simple rational functions like this, you can kind of guesstimate horizontal asymptotes and then just use some plotting of points or even just check in Desmos to see if that's going to give you the answer you're looking for. However, if you want to use a little bit more diligence in looking, the long version, which you may remember, is you use division. Now, what does that mean? Well, the division that I'm talking about is you actually divide, and here's where having this multiplied out form, you take the multiplied out form of the numerator and the denominator and actually divide them. Oop, I haven't given myself a lot of room, but let's see if I can do it. Unfortunately, with trinomials like this, we're not able to use synthetic division. So this is old school long division. What times x squared gives me 2x squared? Well, 2. And then I multiply 2x squared plus 2x minus 4. And then I grab my red pen of destiny and I change all the signs. And then I add. And I get 0x squared, 5x, and this is 0. And so the remainder here is 5x. And so the full answer is that it is equal to 2 plus 5x, which still needs to be divided by x squared plus x minus 2. Now, in this form, we can take a look at this and see that as x gets really large or x gets really negative, this g is going to get really, really close to what? It is going to get really, really close to 2. And by looking at the remainder, we can determine whether or not, so as x gets really, really positive, g is going to get closer and closer to 2 from above, because this whole thing would be positive. And as x gets really, really negative, well, x squared is the biggest piece of this, and x squared is always positive, right? When we're talking about real numbers, that's always positive. And 5x would be negative, so we'd have a negative over a positive. The second one, g would get closer and closer to 2 from below, from the negative side. Okay, so, and I feel like I should have drawn a line here to separate them. So the range of g, very simply, is the y is not equal to 2. Let me scooch this up. But there's a lot of inspection that we can do here to help us determine how it's going to come close to 2. So as x gets very, very large, g is going to approach 2 from above. So it's going to come down towards 2. Whereas when x is getting closer and closer to negative infinity, which is just another way of saying x gets very, very negative, g is approaching 2 from below. So it's coming up like that. Okay? So we've got a situation where we've got the middle, and then at some point we've got it coming down close to y equals 2 over there. And then we also have it coming up, coming close to y equals 2 there. So that's the end behavior. Now, there are 2 vertical asymptotes. And so that suggests to me that there's a lot going on here. So I'm going to go ahead and grab another piece of paper because we're almost out of space. And I'm going to actually do one more piece of analysis on this to help us graph it. And that is, and no one will be surprised to hear it, it's a chart. You know how I love charts. Charts for everything. Woohoo! Okay, so let's take a look at all of our zeros. This is going to give us -4, -2, 1, and this one's going to give us 1/2. Take a look at that, see if you can see it. If not, ask questions. Obviously, you can't ask the video screen right now, but, you know, stop the video, find a tutor, find a friend, find someone on the street, say, hey, you want to do some math? We could bring together the whole world under a beautiful, mathy, happy, peaceful umbrella, right? Okay, so we're going to go ahead and set up a chart for this. So I'm going to get my number line. Let's see, I've got -4. Now, I am going to make this not to scale, the magical words. My number line is not going to be to scale, so I've got space in between everything. 1/2 and 1. 2x minus 1, x plus 4, x minus 1, x plus 2. Okay, so first thing, I'm going to go through, and for each one of these, I'm going to mark where each one is 0. X plus 4 is 0 at 4. X minus 1 is 0 here. There we go. And x plus 2 is 0 at -2. So I've got a bunch of zeros. Okay. And then all of these lead with x. So 2x minus 1, x plus 4, x minus 1, x plus 2. Hopefully you remember from doing this a lot that that means that we're going to have a bunch of minuses and then a 0 and then a bunch of pluses. Now, If you can't remember this, simply pick test points like -5 and say, okay, 2 times -5 is -10 minus 1, oh, that's -11. X plus 4, -5 plus 4 is -1. -5 minus 1, that's negative. -5 plus 2, that's negative. Okay, at -4, this one's negative, this one's 0, this one's negative, this one's negative. We could pick another test point right here in between. This is going to be negative. -3 plus 4 is actually positive. Negative, negative. And then so on and so forth. Basically, it's going to be negative till you hit 0, and then it's going to go positive. When does it go the other way? If you have something like 2 minus x, if you reverse the order, then you're going to end up with pluses and then minuses. But these are all going to be minuses and then pluses. So let me see, there's a point in between there. There's going to be a plus and a plus and a plus. So this is going to be plus, 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 plus. Minus, 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 plus. Plus, 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 plus. Okay. So there are 2 different types of zeros going on. For 1/2 and -4, these are on top. So that's going to make the whole function at 1/2 and -4, the whole function's just going to be 0. Now the other 2 zeros are in the denominator, and so they're going to create a problem. And I'm going to put a U there for undefined. Okay, 4 minuses, make a plus. Doesn't matter. There's a 0 involved. It takes out, doesn't matter whether everyone else is positive or negative. 3 negatives makes a negative. 2 negatives makes a positive. 1 negative makes a negative, and a bunch of positives make a positive. Now, how is this going to help me? Well, this is going to help me with the shape. And already, hopefully, you're looking at this going, huh, there's some really interesting stuff going on here. What else can I do? Well, honestly, what you could do is we could go ahead and start graphing just to sketch it out. So very, very light sketch. This is going to be a very sketchy sketch. So what sort of things are happening? Well, from the first page, I know that I've got 2 vertical asymptotes and I've got 1 horizontal asymptote. I should put those in. I also know that the horizontal asymptote has this kind of behavior like this, which I can also see from this little chart. So there is some duplication of information. Okay, so let me go ahead and draw in my 2 vertical asymptotes at x equals 1. You see that? Squish it up a little bit more. And then x equals -2. Now, this starts to get really busy because you got all the numbers and everything. So you may want to be kind of stealthy about how you write in your numbers so you don't take up too much space. When, and you can't quite see it, so let me scooch this down. When x is 1/2, y is 0. And also when x is -4, y is 0. So I'm going to find those 2 points. Pardon me. Here, Sharktopus is trying to get out of it. Sharktopus is like, nope. And I'm going to say, oh, Sharktopus, it really is okay. So this is -4 right there. And then I've got a point right there that's 1/2. Okay. Then I also have a horizontal asymptote at y equals 2. Personally, I would have some trouble graphing this. I've got some ideas. This point seems very likely to be doing this, right? This little branch. But this guy, I'm not quite sure what it's going to be doing. There are many, many things it could be doing. It could be coming up this way and down this way. It could be coming up. It could be coming down. one thing I can do is I can look at this and I could say, okay, the graph is positive here and it's negative. So right here between -4 and -2, I know that this is going to come down because I know it's going to be negative. And I know this one's going to be positive, so I suspect it'll go up like this. So I feel pretty confident about that. Here, between -2 and 1/2, I've got the vertical asymptote and a very hungry crow. I'm not sure if you can hear the hungry crow outside. He's yelling at me. He wants breakfast. I served breakfast 6 hours ago, so they can wait. They get up late. They wait for breakfast. In between -2 and 1/2, it's going to be positive, which is interesting. So it means that from here, I'm going to go up in some direction. I'm not feeling very comfortable with that. Not very confident. So what I'm going to do is I'm going to plot some points. Now, if you happen to have a very carefully constructed chart, you know, I just put in the pluses and the minuses, but some people actually do, like for here, for -1, that point in between, if you actually have the values written in, you can multiply them out, and instead of just getting a plus, you could get that value. You could know what it's equal to. And in which case, this chart is something you can graph from. I don't tend to do that, so I'm going to go ahead and just plug in -1. So I'm going to get -2 minus 1, -1 plus 4, -1 minus 1, -1 plus 2. Okay, so that's -3 times 3 all over -2 times 1. So that's going to be -9 over -2, so that's going to be 4.5. Interesting. So that's going to be 4.5. So if I come over here to my graph, when x is -1, y is going to be 4.5. Okay. And suddenly, this is giving me an interesting result. Now, in addition to this, I'm going to take a look and I'm going to say, okay, so this is positive in here and somehow negative down here. So I think this is going to look something like this. Oop! Oh no! That's the edge of the paper there. Sorry about that. Something like that. Okay, not too bad a guess. Let's see how that pans out. And again, over here, I think it's all going to be positive, but maybe it's going to be up here, down here, who knows. So let's go ahead and plug in not x equals 1, but maybe x equals 2. Let's try x equals 2. And of course, you can plot whatever points make the most sense to you. 4 minus 1, 6. 2 minus 1, 4. So let's see, 3 times 6 all over 1 times 4. So that's 18 over 4. And this is really interesting. We've got some interesting symmetry here. And I did not plan this, it just happened. But sometimes that happens, you know, brains being the way they are. So when x equals 2, y is yet again 1, 2, 3, 4.5. And I'm going to look at this and say, okay, I'm expecting it's going to come down but stay above y equals 2. So my guess is going to be it goes like this and it comes down like this. Now, if I were you, I'd be looking at this video going, great. So the math teacher is saying this is all obvious, but it's not obvious to me. So what should you do if this is not obvious? Well, the more complicated this is, perhaps the more points you want to plot. You could plot 10 points. You could plot 100 points if you wanted to. Really dig in, see what this function is doing. As you can tell, I've got kind of a wonky graph right here. That's very sketchy. It's not very specific. And I might be wildly off. Shall we check? Dun 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 dun! Through the magic of television, This is my Desmos version of the graph. I do have this y equals 2 right there. I've got my x equals 1 and my x equals -2, which you can't see, which I'm writing in. And you can see I've got the graph that comes down like this. I've got the middle part that does this. And then I've got this other branch that does this. And that's actually not too far off. Woohoo! So, what are the questions at the bottom of the page? Can a graph cross a horizontal asymptote? Yes. Horizontal asymptotes are tendencies as x gets very, very big or very, very, very negative. In the middle, all sorts of shenanigans can happen. So can a graph cross a horizontal asymptote? Yes. Can a graph cross a vertical asymptote? No. Because the vertical asymptotes are actually problems with the domain. And so all of this had to do with the range. When we look at the domain, though, those are absolute. So vertical asymptotes, nobody crosses. No how, no way. Woohoo. Okay, so for Sharktopus, I would like to say you guys are amazing and awesome. And please don't hesitate to ask questions. We've got one more complicated problem to do in this section, and then we will move on. So go get yourself a snack and something, to quench that thirst, and we will come back and do some wonderful, exciting math. So, woohoo, math on.